Hello everyone, I hope everyone is doing good and welcome to the channel. So in today's video, we are going to look into the interview question regarding LLM. So nowadays you would be seeing that any senior level data engineer interview or a mid-level data engineer interview also requires some of the GenAI. Like in the JD, you would be seeing that there is a mention about the GenAI, like good to have a GenAI. And internally in the interview process, they have bifurcated this GenAI part into LLM RAG system and the other project related rating. So if you are a data engineer of mid level or a senior level and you want to crack a good interview, good companies for the data engineering skill, then you should have some of the skill of GenAI, be it only LLM specific or be it RAG specific, but anything or something about the Gen AI should be added into your profile to it will help you to land you to a better job. So this video will focus on the LLM interview question. I will be not going into the detail of the answers. The topic will be there, and most of the topic has been explained in my previous multiple other videos in multiple playlists. So do subscribe to the channel, help it to spread to your colleague and friend so that people may get benefited who want to get into DE field, who want to upgrade themselves into DE field, who want to get into some part of the Gen AI related to data engineering. So we'll start the video now. So the first question will be very simple question. If you are a mid-level data engineer, so the first question will be to explain what is LLM and how does an LLM work. So you have to tell first the full form of it. It stands for large language model, and then you have to explain that what is LLM. So LLM is a model, pre-built model, which has been trained with large number of parameters, with large number of text document. It has learned from multiple training data set so that it can summarize and give you the contextual answer. So it is a model which can predict the answer to the question which you have asked to the LLM. It is a text generated output. So you can think of an LLM as a very advanced next word prediction engine that has learned pattern from billions of documents. So just understand, like LLM is a model, like machine learning model. If you have some background of machine learning, you would be understanding that with the help of Python framework, you create a model, machine learning model, and you give some training set, data training set to get it trained so that it can predict the answer next time when you ask the question. So if you create a model and and it gets trained in with the help of billions of documents, images, multiple things, and multiple parameters into it, then that becomes a very huge intelligent model. So that we call it the LLM, large language model. So example of it is your chat gpt, your Gemini, Google Gemini, your Meta, your Olama, and there are multiple other cloud has come up with their LLM model. So LLM model is a very intelligent model trained with a large amount of data. Now we'll see that how does it work? How does it internally work? So working of LLM is very complex internally. Okay, so you don't need to get into very detail of it unless until you are targeting the company organization where it is very specific, like the work is very specific to LLM training or customization of the LLM model or creating a new LLM model, which is very rare to happen. But if you're targeting this kind of company, this kind of product based company, then you need to go into this topic in detail, like transformer and the NLP, the detail of the NLP. So if you want to understand transformer in more detail, I have a separate video. I'll just post it in the description where I have explained transformer in very detailed way. For the interview purpose, it for the most of the company, you have to say that there is a text data, there is a tokenizer, internally when you give the query or when you ask the LLM like what is the capital of India. So that sentence, that questions is a text data, it goes into LLM. There is a tokenizer. There are multiple algorithm of tokenizer which tokenize the sentence. I'll come into it. What is tokenizer? It tokenizes the sentence, break into small parts, create it into token wise. There is a transformer model which tries to bring all that near to meaning token near to it so that the semantics of the meaning can be taken out. It's a very complex process. Transformer model is a very complex process. I'll just post the video in the description. Then there is internal training, and then next token prediction is given. For example, you are asking what is the capital of India. So the answer means the next token prediction will be Delhi, New Delhi. So this is how the LLM works in the high level. So for a data engineer, if you say this much also, that will be good. But if you want to, if they are going into detail of it, then just Google it and try to learn a little bit more inside it, and that will be okay for you. But if you're a data science, this video is not for a data scientist. But if you are a data scientist or you have worked with in a machine learning for a couple of years, then you need to know more details of it. So now the next very important question is, what is token? Like if you would have worked with LLM or any of the GenAI pipeline where LLM is getting used, the model basically. So it'd be there must be a discussion in the team around the token size. What is the token size? How much we have to pay for the token? How, like for one query, like how many token size will be there? So token is very important. So token are the smallest unit processed by an LLM. Like if you tell the LLM like what is the capital of India, so what is the capital of India? That sentence the LLM will not understand it directly. It will break into small parts. Like what can be one of the token, India can be another token, or any sentence India can be broken into two part to make two token. So it depends on how the tokenizer has worked on it. Like now, there is a concept of tokenizer before the number of token is decided. So tokenizer helps with the help of algorithm to decide on what will be the token size. So the token can be a word, it can be a part of the word, it can be a punctuation. Like if you ask question mark, what is the capital of India, question mark, then that question mark can also be a token. A special character can be a token. So now I've just written an example. Artificial intelligence is amazing. So artificial intelligence is amazing. This can be a separate token. So in this four word, it has four token. Now the question is why token is important. Token is important because LLM doesn't understand, your machine does not understand the word. It understands the numeric value. So token is a chunk of text that an LLM converts into numerical representation before processing. Your token, for example, artificial is one of the tokens. So uh, the what you call corresponding number or corresponding numerical representation of artificial will be given by this algorithm, by the flow what happens inside the LLM. So each token is given in numerical values, and LLM then understand these numerical values. The token which has the numerical number near to each other, that means the contextual meaning is a bit similar to that. There are multiple other things in the transformer, as I mentioned in the first question. Like transformer is one of the important thing. So transformer is important to give the number to the token, so the transformer will understand the meaning or the word, what the word is saying with the help of that token, and transformer work on that token number. So if you have to, as a data engineer, if you have to explain the token, you can say it's a smallest chunk in the LLM, which gets converted into numerical representation, and that helps the transformer to work the it's a transformer is the brain of LLM, so it helps LLM to work on that. Fine. Now, what will be the token size? A word will be a token, or a group of word will be a token, or a word can be divided into two token. For example, intelligence. So intelligence or artificial, it can be broken into two part. So a word can be a two token. Who decides that? That is decided by the tokenizer. Which kind of tokenizer has been used, and the kind of tokenizer being used helps to decide on the number of tokens or kind of tokens from the text which you give to the element. Now the next question is, what is tokenizer? So what is tokenizer? So tokenizer, as I mentioned, it converts human readable text into a machine readable tokens number. So for example, generative AI, and generative AI, I consider it as a two token. So one token is generative, another is AI. So generative has been given a number, AI has been given a number. So if you talk about how actually it works, tokenizer, there is a text, there is a tokenizer. Tokenizer, with the help of algorithm, breaks it into different tokens. That is tokens. Each ID is given to the tokens. Embedding is created. Then LLM processing is done inside it. So this token embedding, LLM processing, this happens inside the transformer. Output token is given, and that output token is converted. Means obviously that number is converted into output tokens, and that is the generated text. Don't go detail into the tokenizer as a data engineer. Just understand that There's a numeric value given to each token. Who decides the token? Your tokenizer algorithm decides the token. There are multiple ways, multiple algorithms in the tokenizer. Now, other important question is what is the transformer architecture? I'm not sure that this question will come to you as a data engineer, but I have seen practically like there are people who ask this kind of question and they don't expect it in the detailed answer, just an overview. So you can say that transformer is the main foundational layer of LLM, or it's the brain of LLM. And there are multiple components like attention mechanism, multi-thread attention, feed forward network, positional encoding. You don't need to go much detail. A overview. I have other interview questions in the same video regarding each of the topic. What's the meaning of this? And if you want to have a detailed knowledge about how transformer architecture actually works internally, I'll just post the video link. So the advantage of transformer is it handles long context. So now if you are telling the LLM like uh, uh, what kind of cat I should buy, the cat should have a long hair, it should be black in color. So just help me to understand which kind of breed I need to buy for the cat. So in this kind of long sentence, to understand this long sentence, transformers comes into the picture because that will be divided into a small token. Token ID will be given then, but transformer comes to understand the context of that sentence, and the parallel processing happens because if you give a long sentence to a transformer, and if transformer tries to understand the meaning of all the small words, it will become it will take long time to understand it. So what does transformer does? There will be multiple parallel processing will be working on the same kind of same text, same long sentence, and that makes the process bit fast. And there is a better understanding between the relationship of the word, and it's a very complex process. How the what is called context of that sentence is being understood. But anyway, this is the main component, small component. You can also you can tell the interviewer like the process multiple processing happens, parallel processing happens. There is an attention mechanism. There is a way to understand the context between the words. That will be enough for it. So now the next thing is what is attention, which we have discussed. It is a part of one of the architecture part of the transformers. So what is attention? So attention helps the model to decide the which word is important. Like for example, the sentence is Dhruv went to school because he had exams. So this he refers to Dhruv. So this understanding attention makes the LLM understand, or the transformer understand like what is he in this. So attention also focuses on the he reference. It understand like he should be referred to some other some of the noun. And this happens this what do you call this intelligence comes with the base intelligence of natural language processing, NLP. Like this is a pronoun, and that this will be connected to some of the noun. So like had is not connected to Dhruv, he is connected to Dhruv. This understanding also attention mechanism brings it to picture. So in a long sentence, the meaning or the relationship between the word is being understood by the attention. Okay, and every time it may not be correct, but it tries to give, most of the time it tries to give the correct answer or try to understand the correct answer. Okay, so this is the first phase in the transformer. So now the next question is what is self attention? So self attention is like a revolutionary thing in the LLM field. This the LLM only has this feature. The NLP, multiple algorithms, NLP also don't have this kind of feature. Like what is self attention? So self attention, each word actually compared to other words in the same sentence to understand that how strongly it relates to the other word. So self-attention allow every word to look at every other word in the sentence. For example, the cat sat on the mat. So what model will decide like how the relate to cat, how the relate to sat on the mat. Similarly, the other word how it relate to other word, and this creates a matrix in which it is being seen that how this word one word is related to other word, how closely and how strongly, how meaningful. Strongly means meaningful, and that brings the overall context to this full sentence. in a bigger sentence, this kind of comparison becomes very difficult. So there the processing, parallel processing of the transformer comes into the picture. So now the next question is, what are parameters? So like you, if you go through any of the vlog and your discussion, you'll be hearing about like a particular LLM model has been trained with these billions of parameter. Other like if a model is very big, is very popular, then that model has been trained with multiple billions of parameter. Parameter means the feature inside the neural network. See, this LLM is based on the neural network, and it's also based on the NLP, natural language processing. So there are, like, you have to give the feature, like you have to understand the understand the model, like on which particular feature it has to learn. So if that feature or that parameter, which we call it, has it crosses multiple numbers, then that LLM becomes a big LLM. For example, 7 billion parameters. Like you would have heard about deep search. The deep search model has been trained with I think it was 100, more than 100 billions parameter. Generally, more parameter means higher capability. Obviously, if your LLM model has learned from a multiple features, so then that model is more capable to work on multiple domain. It will be have more horizontal domain with more precise and contextual outcome. But more parameter, if you train your LLM model with more parameter, than the infrastructure cost, because uh, if you're giving multiple many parameters, and that model itself is a complex model, that the set of programs, then there will be huge CPU and GPU cost in getting it trained for each of the parameter. So obviously, if more parameter, then higher infrastructure cost. And this is the main reason that all other companies are not building their own LLM. LLM is already, if you see, the LLM is built by all the big companies, Meta, Google, that Gemini model, that Cloud, Anthropic. So these bigger companies which focus only on creating the LLM models, because LLM models, if you have to train or if you have to create LLM models with the, obviously you have to give billions of parameter, then the CPU cost, the GPU cost will be huge, and that other companies can't afford it. And that's the reason that LLM is not being created by all the companies. People use the LLM, people try to train them or mold it in their use case ways, but generally the bigger LLM are created by the specific kind of company. Now the other question is, what is context window? You'd be hearing about this particular model has this is the context window. Like one time, or at one time, how many information that LLM can process. So there's a limit to it. If you give a long sentence, long document, but there's a limit for each LLM model to process it. Like 8,000 token, 32,000 token. You have given the information that is being divided into multiple tokens. So what is the limit of the token that LLM can process in a single time? And that is the limit of, actually that is the limit of the LLM, what we call it. So that is the context window. So next time in your any kind of discussion, if you come, if there is something discussion going on the context window, that means they are talking about the token size, and that will be eventually being aligned with the prompt what you are going to give into the LLM. So basically, in the bigger project, there are bigger prompt. There is a complex prompt. So there's always a effort to reduce the prompt, keeping the meaning very much intact into that limited prompt, and also to check that that prompt can be processed by at once in an LLM model, so that the context, the semantics of your prompt remains the same inside the LLM. So knowing about the context window of all the LLM model is very important. Like any of the model, if you're going to use, for example, you're going to use any Gemini model for documentation purpose, so you should know what is the size of the token. Next, very important question is, what is hallucination, and how can we reduce hallucination in LLM? See, LLM is a model. It's a fantastic model. You ask the question, it will give you the answer. Now, multiple times you will see that it will not give you the question in very much of a context or semantic what you have asked. The answer may be wrong, or the answer may be near correct. It will not be 100% correct most of the time. Not most of the time, in some of the times. So that is called hallucination. Like that, it's not giving the correct answer. So if you ask one question, if one question, it gives you the answer. Then if you start asking multiple questions around the same prompt, then you will observe that it deviate from their answer. So that is called hallucination. So how to reduce this hallucination? The very good answer to it, or the biggest thing is to reduce the hallucination, is the RAG system, RAG. I have multiple videos on the RAG. You can look into the playlist of the GenAI. RAG is a technique in which we give the external information to the system pipeline. We extract the data from the external information, means what we keep in a vector database, and that information is only given to LLM. So it is, we make it in, we ensure that LLM only use the information which it has got from the vector database. Like the information which has been retrieved from the vector database, only that information the LLM should use to give the response in a proper way. And that LLM should not use its own generic knowledge or the Google search of it, or in Google search means any of the search, internet search. So RAG is one of the system. Ground truth validation, like there is a list of question answer. You ask the LLM system. If you are getting same kind of answer, then you can understand what will the accuracy of that LLM. So that is another way. There are other multiple evaluation metrics of the LLM. But RAG is a fantastic solution, and it is being asked to multiple. If you are a senior data engineer going into a better role of data engineering, then they will ask you, surely ask you question around the RAG. And if you clear the question of the RAG, I have already created the RAG interview question. The question will not come out of that particular video. So if you are able to answer that, if you are able to convince the panel that you know RAG and you understand the RAG system, then you will get a very good position in the job. So this is important, hallucination, how we reduce the hallucination. Now, once the question around the hallucination starts coming, so obviously the interview will go around the RAG. So they'll ask you, what is RAG? Try to explain me the RAG. Have you worked on the RAG system? So you have to you have to prepare with the RAG, one of the project with the RAG, or at least some of the POC with the RAG. You have to make you have to understand, like you have to give the answer in this way. Like there's a user question, there's a and that user question is broken into small chunks, then vector search is done, retrieving the document is fed to LLM, and then LLM generate the answer. So RAG is important. Try to understand RAG. I'm not going to explain RAG in this video. This is more of a question answer. Go to my previous video. Then what is embeddings? So in vector, while creating a vector search or creating a data inside a vector, you create a chunk of the information. That chunk of the information is created into multidimensional vectors, given the number to each of the vector in the multidimensional. So that is embeddings. What is vector database, which stores the embedding in a to have a semantic meaning, semantic truth. So that is a vector database. There are multiple examples. I've already discussed this. So for the LLM interview question, be prepared with the RAG interview question also. If you don't know RAG, you can see that I'm not worked on the RAG, but I've used LLM in multiple things. I have understanding of LLM, and these questions, the other questions inside LLM will help you to do that. But if you have time, then go through the RAG. At least have the theoretical knowledge of RAG. That is very important. I have a different video where I have discussed about in detail of all the RAG interview questions. Nothing is going to come out of it, straightforward question. But yeah, of course, regarding the project and scenario-based question. For scenario-based question, also I have created another video. You can see the playlist. But you will in the scenario based question video and the direct RAG interview question video, if you combine that, you will get all the questions. That will be enough, more than enough for you to crack the interview. The other question can be directly like, what is prompt engineering? If you know prompt engineering properly, see, prompt engineering is a way of giving a proper prompt so that LLM also understand what you are asking in a contextual way, and what answer you expect. The goal should be clear to the LLM. For in a prompt engineering, there are multiple ways to write the prompt: zero sort, one sort. So there are multiple sort. If you don't want to go into detail of it, that's fine, but just Google it. It's very easy. In just 1 or 2 hours, you will understand what is prompt engineering. You will understand to write the prompt. You will understand to differentiate between different types of prompt. Then the AI agents, you're learning about LLM. So LLM can be used to create multiple works parallelly or one by one with the help of agents. Agent means one task. How in a normal programming language you have multi-threading, multiple threads working parallelly or working one by one in a different task. So there can be multiple agents, there can be single agents, single thread, multiple agents with multiple threads. So these agents are a specific task being performed independently of the main task on with the help of different LLM model. For the AI agent also there is the previous video of this has been explained. Now, if you are comfortable with the previous interview question when you are in the interview process, then the question may come like if you have to design the enterprise LLM application. So how you will RAG is one of the LLM application very popular. So how you will design that? So you have to give a very mature answer. The answer may not be 100% correct, but logically it should be correct. So you have to start with like there will be multiple data source. You have to create a data pipeline, means extracting the data from multiple data source. That can be done with the help of Python. That can be with the help of PySpark. There can be a data cleaning process inside that. So you have to talk about that because as a data engineer, you should be very good in extracting the data, explaining it, creating a data pipeline. Then chunking will happen, breaking that information into small pieces. Embedding will happen, creating it into multi-dimensional vector. Then embedding will be stored somewhere. So we need a vector database to store that embedding. Then with the help of query search, you will retrieve the information out of the vector database. That will be moved to the LLM. That retrieve information will be given to LLM, and then LLM will give the output. There will be guardrails like which kind of information that LLM should give out. If it's a financial information, then that kind of information, if it is retrieved from the vector database, then LLM should not give that information as in the response. There will be monitoring dashboard to monitor the performance. There will be evaluation matrix also to like if you have to check. Like for in the LLM, there is a hallucination process is a bigger disadvantage. To tackle that, we have a RAG system. So this is basically a pipeline of the RAG system, but RAG system also hallucinate multiple times. So for monitor that, for looking into that or tracking that, we should have a evaluation matrix. These all things I have already discussed in the previous video, but you should understand this. I think these all videos, this LLM interview questions videos, the RAG interview questions, which I have created 2 videos. If you combine all these 3 videos, it will be a master interview questions list. And I think this will be useful for a specific person who is not from a data engineering, but also try to directly going into GenAI. But if you're a data engineer, then it's going to be helpful to you 100% if you are moving into a bigger role. I hope you will be able to understand it, track it in a proper way. You'd have seen that I have not gone into the solution for each question in detail because I have already explained in the previous video. I don't want to make this video a very long video. I want to make it short and precise. If we have any question, please post in the comment. I'll come up with the solution. I will answer in the comment. We'll meet in the next video. Till then, goodbye and happy learning.